We are continuing to perform operations on rational expressions. Thus far, we know how to multiply two rational expressions, we know how to divide two rational expressions, and now we are going to add or subtract rational expressions when the denominators are not necessarily the same. Remember, to add or subtract rational expressions, we must have a common denominator. So here we are adding two rational expressions. To add rational expressions, we look at the denominators. They are not the same, so we need to come up with a least common denominator. Let's see if we can come up with that least common denominator. And if you need to, you can always work on the side to come up with that least common denominator. Notice I have a denominator of x and 2x squared. Remember, we look at the unique factors in each denominator. Here's a unique factor of 2. It occurs once here, does not occur there, so I'll write that down once in my least common denominator. Here I have a factor of x squared. What is the most number of times that that unique factor x occurs in any one denominator? It's 2 times, or x squared. So I'll also have an x squared, and my least common denominator is 2x squared. Again, to add or subtract, we've got to have the same denominators, so we'll take a moment now and we'll write each rational expression as an equivalent rational expression, but with this as the denominator. So let's ask ourselves, what do we multiply x by in order to have a denominator of 2x squared? We multiply x by 2x. X times 2x is 2x squared. Don't forget, if you multiply the denominator by 2x, you must multiply the numerator by 2x, because that is the same as multiplying by 1, so we haven't changed the value of our rational expression. Then plus, let's look at our next rational expression. Well, it just so happens that this denominator is the same as the least common denominator, so we don't need to multiply numerator and denominator by anything. So now, let's go ahead and write this as 6x over 2x squared plus 5 over 2x squared. And look what we have accomplished. We now have the same denominators, so now we can add, and it's numerator plus numerator over a common denominator. These are unlike terms, so we cannot combine. The only hope of simplifying is if the numerator can be factored, but there's no greatest common factor other than 1 or -1, so we are simplified, and this is our sum. Let's keep that in mind and start thinking of some steps that we can write down to use when adding or subtracting rational expressions with different denominators. Let's suppose I have, say, 6 over x minus 3 plus 8 over 3 minus x. Let's get this special case out of the way when adding rational expressions. Look at the two denominators. It just so happens that these two, if you recall, they are opposites of each other. Since they are opposites of each other, I'll just pick on one of the denominators. I'll just use the second denominator, although it makes absolutely no difference. And I'm going to take that second denominator and I'll write it as -1 times x minus 3. Since they are opposites, this one must be the same as, this one must be the same as this. And double check. -1 times x, that's negative x, which is what I have. -1 times -3, that's positive 3. I haven't changed it. I've just rewritten it as an equivalent form. But now, Notice they are almost the same except for this factor of -1. But remember, now again I'm working on that second rational expression. Remember, I can take this negative in a rational expression. I can move it to the top in the numerator, I can keep it in the denominator, or I can actually move it out in front. It makes no difference, but I'm going to take that negative and move it to the numerator, so I'll make it -8 over x minus 3. These two rational expressions are equivalent. And now notice the denominators are the same. So what do we have? We have 6 plus -8 over a common denominator. And what is 6 plus -8? That's -2 over x minus 3. Now don't forget again, you can take this negative and write it out in front. You can write it in the denominator but enclose x minus 3 in parentheses, or you can leave it here in the numerator. Just remember that this is equivalent to, amongst other forms, this form. So again, we've added rational expressions and this is the result. Let's look at this again. Let's add or subtract some rational expressions. Here I have y plus 2 over y plus 3 minus 2. We are subtracting this time. So what is our first step? It's to find the least common denominator. Think of this as 2 over 1. So look at your two denominators and decide on a least common denominator. Well, this is simply 1. We can use this if we want, and this is a factor of y plus 3, so this occurs once, and 1 times y plus 3 gives us a least common denominator of y plus 3. Now, what do we do next? Next, we write each rational expression as an equivalent one, but with this denominator. So, I have simply y plus 2 over y plus 3. Notice this is the least common denominator, so we don't need to multiply numerator and denominator by anything. Minus, I have 2 over 1. What do I multiply 1 by in order to have a denominator of y plus 3? Well, I multiply by y plus 3. And if I do that in the denominator, I do the exact same thing in the numerator because that is the same as multiplying by 1. Now let's see. We have y numerator plus 2 minus numerator 2 times y plus 3 all over a common denominator, and these are the same. 1 times y plus 3 is y plus 3. So over the common denominator of y plus 3. And now we just simplify in the numerator. So this is all part of simplifying. So let's see, we have y plus 2 minus 2y, and then be very, very careful, minus 6 all over y plus 3. Let's see if we have any common factors. Y minus 2y, that's negative y, so I'll write that as negative y, and then 2 minus 6, that's negative 4 over y plus 3. That is perfectly okay. If you'd like, you can factor out a negative 1, and I'm going to write it out in front. If I do so, that's y plus 4 over y plus 3. Many, many equivalent forms here. You can leave it like that. That's perfectly okay. You can factor out the negative 1 and write it out in front. That's perfectly okay. This cannot be simplified, nor this, so this is my difference in simplest form. So let's now look at some steps that we can use for adding or subtracting rational expressions with different denominators. So here are our steps for adding or subtracting rational expressions with unlike or different denominators. Step 1, find the LCD of the rational expressions. Step 2, rewrite each rational expression as an equivalent expression whose denominator is the LCD found in Step 1. Step 3, add or subtract numerators and write the sum or difference over the common denominator. And then Step 4, simplify or write the rational expression in simplest form. We have in essence been doing those 4 steps. I'll mention them to help you refer later to the steps, but let's just go over these as we work another, in this case, subtraction of rational expressions. I'm subtracting, so the first thing you need to do is look at the denominators. They're either the same or they're different. These are different, so we have some work to do. We need to decide on the least common denominator. To do so, we haven't had a case like this before, but it's easier to look at the factored form of each denominator. And I'm mentioning that because notice this denominator, there's a greatest common factor of 2. So let me just rewrite this. That's 3a over 2 times the expression a plus 3 minus a minus 1 over a plus 3. Now let's concentrate here and decide on the least common denominator. There's a unique factor of 2 here, not 1 there, so the most number of times it appears is 1s. And then there's that factor a plus 3 here and here. But remember, the most number of times that it occurs in any one factor denominator is once. So we only need it once in our LCD. So there is our least common denominator. Now what do we do next? Next, we write each fraction as an equivalent fraction with this as the denominator. So that's step 2. Let me rewrite the first rational expression down. That's this rational expression. And then just compare this denominator with the LCD. Notice these are the same, so it just so happens that the first denominator is the least common denominator. I can then move on to the second rational expression. Now compare this with the LCD. What do I multiply this denominator by in order to have the least common denominator? I simply need to multiply this by 2. Now if I multiply the denominator by 2, I must multiply the numerator by 2. Now the denominators are the same. Don't worry about order. Remember, multiplication is commutative. So a plus 3, that quantity times 2 is the same as 2 times the quantity a plus 3. But now that we have the same denominators, we simply write numerator minus, now if you don't mind, I think I am going to write that 2 first, times a minus 1 all over a common denominator. And now let's start simplifying. First, we'll use the distributive property and be very, very careful here. We are subtracting, so that does distribute. So we have 3a, now that's minus 2 times a, so that's minus 2a, and then negative 2 times negative 1, very, very important here, that's positive 2. So that's plus 2 all over 2 times a plus 3. So, is there any simplifying in the numerator? Yes, we have a few like terms. 3a minus 2a is 1a, or a, plus 2 over 2 times the quantity, a plus 3. Is there any simplifying that can be done here? Can I divide out these 2's? The answer is no. This is a factor, but this is part of the expression a plus 2. There is no simplifying that can be done. This is the difference in simplest form when we subtract our original two rational expressions. Let's now add these two rational expressions. It's addition. Look at the denominators. They are not the same, so we need to find the least common denominator. Don't forget, we need to look at the denominators in factored form to find the least common denominator, so that's all I'll do at the moment. I'll factor that first denominator if I can. I'm looking for two numbers whose product is -6 and whose sum is -5. That's -6 and a +1. I'll let you check the factoring. Plus, in the numerator, x plus 1, and let's see if that second denominator factors. I'm looking for two numbers whose product is -5 and whose sum is -4. That's -5 and 1. Now, let's decide on the least common denominator. Remember, you just look at the unique factors. This is a unique factor. It occurs once in the first denominator, not at all in the second denominator, so I write it down once. This is a unique factor. It occurs once here, most number of times in any one denominator is once, so I write it down once. Here is a unique factor. Once here, none there, so I write it down once, and I've taken care of that factor. Believe it or not, this is my least common denominator. So just be very careful and neat in writing, and we'll be just fine. We work it just as the other ones. I'm going to now write each rational expression as an equivalent rational expression, but with this as the denominator each time. So I have x plus 8 in the numerator right now. What do I multiply this denominator by in order to have this denominator? Well, I already have this factor, I already have this factor, so I multiply the denominator by x minus 5. I must do that same thing in the numerator. And now let's move to the second rational expression. I have x minus 5 in the denominator, x plus 1 in the denominator, and coincidentally, an x plus 1 in the numerator. Now, check this denominator with the least common denominator. What do we multiply this by in order to have that LCD? We multiply this by x minus 6. If I do it in the denominator, I must do it in the numerator. Now, the good news is that these denominators are now the same. So now we can write this as numerator plus numerator over a common denominator. As I write numerator plus numerator, I'm going to go ahead and start multiplying these factors in the numerator together. What is x plus 8 times x minus 5? First times first is x squared, outside product, minus 5x, inside product, plus 8x, and then last times last, minus 40. Now this is a plus sign, so I don't need to worry about signs changing, and let's go ahead and multiply these two. X times x is x squared, outer product, minus 6x, inner product plus 1x or x, last times last, minus 6, and then this is all over a common denominator. So I'll write it over x minus 6 times x plus 1 times x minus 5. And now we just need to simplify in the numerator. So let's see, I have x squared plus x squared. I'm looking for like terms. That's 2x squared. Now be very careful. Negative 5x plus 8x, that's 3x. 3x minus 6x, that's negative 3x. And negative 3x plus 1x, that's negative 2x. And you need to go through and double check on me. And then minus 40 minus 6, that's minus 46 all over that common denominator. X minus 6, x plus 1, x minus 5. What do we need to do next? Well, we just need to factor the numerator to see if this expression can be simplified. Now, what is the first step in factoring the numerator? Well, I know we can factor out a 2, and I'm left with x squared minus x minus 23 all over that LCD, x minus 6, x plus 1 times x minus 5. Now, can I factor this further? If so, I'm looking for two numbers whose product is negative 23 and whose sum is negative 1. Don't forget this is a prime number, so there are no two numbers whose product is negative 23 and whose sum is negative 1. So this is as simplified as it can get. In knowing that, you can write it in this form or this form because there is no simplifying that can be done. We have added those two rational expressions. Here's the sum, or equivalently, here's the sum. Let's review then. How do you multiply two rational expressions? Numerator times numerator over denominator times denominator. How do you divide two rational expressions? It's the first rational expression times the reciprocal of the second rational expression. And how do you add or subtract rational expressions? You've got to have the same denominators. All right, at this time, practice working operations on rational expressions.